All right. Hey, everyone. I hope you're all having a great beginning of the hackathon and the conference. I'm Daniel. I'm one of the DevRel engineers at the SWE Foundation. I work very closely with SWE and Walrus. So today I'm going to be giving you guys a high overview of what SWE is, what Walrus is, and how we're having them work together to decentralize the internet. Okay, so I'm going to talk about SWE first. And I'm going to bring up 3 of SWE's superpowers. First is the object model. One of the biggest difference between SWE and EVM chains is the way we represent assets on chain and the ownership of those assets. As a developer, it's absolutely crucial that you understand how these assets are represented on SWE and how you can create these assets and manipulate them. And then we have Move. Move is the smart contract language that we use to develop our smart contracts. This will basically allow you to create assets on chain and the logic to manipulate these assets. And then we have our bread and butter PTBs. PTB stands for Programmable Transaction Blocks. I'll go into detail about it later, but it's a way to allow client-side developers the power of a smart contract developer without any need of smart contract experience. Okay, so on SWE, the rule of thumb is that everything is an object. When you deploy a smart contract, it lives on chain as an immutable object, and it is used to manipulate other objects on chain. Global resources such as liquidity pools, marketplaces, NFT metadata, those are typically stored on chain as shared objects. A shared object can either be immutable or mutable and is accessible by anyone on chain. And then we have owned assets such as coins, NFTs. All of these owned assets, personally owned assets, are represented as owned objects. So an owned object sits directly in your SWE account, and only you, as the owner of that object, have the ability to access it and manipulate it. And also, objects can own objects as well. You can have nested objects on SWE. That's kind of how a liquidity pool works. A liquidity pool is a shared object that can have coins in it. As a nested object. And it's important to note that because owned objects can only be touched by that account, you can parallelize these transactions, which one of the reasons why SWE is so performant. So the main takeaway with the object model is we want our digital assets to behave like physical assets. So like, let's say you're going to pay cash for a coffee. You want to give the barista a few dollar bills, each nominated with its own value, like let's say a $10 bill and a $5 bill. They're all individual bills that have its own value, and it's the same on SWE. If I wanted to transfer you SWE or buy an NFT, I would transfer either one or a few objects, let's say a SWE coin object, where every object is nominated with a certain amount of SWE in that object. And then another example, let's say like your buddy wants to borrow your Lambo, take it for a drive. There's 2 things you need to give your friend. You need to give him the actual car, let him know where to find it, like in the garage. And you have to give him the keys. Keys are a physical object that allow you to operate the car. So it's the same, let's say you're a founder of a DEX, and you want your founders or your devs to have certain abilities to modify the configs. You have to mint them an object that their SWE account owns, and ownership of that object allows them to modify the configs of that protocol, whatever that is. And the reason we represent asset ownership this way is because it's really easy to understand, because we deal with physical objects all the time, so it makes sense to have your digital assets kind of behave the same way, and it makes everything interoperable by default. So when you deploy, if you deploy a contract here, each with different types of objects, these objects are compatible by default, meaning that anyone can build with any of the objects. There's no need for like wrapper contracts or anything like that. Okay, so the SWE object model, that's the mindset you need to have and you need to understand when developing on SWE. And then we have Move, the smart contract language. So I'm going to show you how this SWE object model is then translated into the code. So we have this buy function here. And this buy function will take in a coin. So let's say you as the function caller own this coin object. You pass it into this function when you're calling it, and that will relinquish your ownership of the coin. So at this point, when the function is being executed, the function has complete control of this coin object. You no longer own it. The only way you would own it after the function is if it's given back to you. So yeah, so the coin would probably be sent to whoever owns a contract or whatever, and then in return, you're given a car title. This car title object is then sent to your account, and it represents ownership of this car title. And then let's say you have this car title, and you want to register your car. So instead of relinquishing ownership of the car title, you want to just prove that you own it. You want to just show the function that, like, hey, I own this specific car title. So you do that by passing in an immutable reference to it. So at this point, you're not actually transferring the car title. It's still always going to be in your account. The function just has the ability to read the data that's in that car title and prove that you own it. And then there's like a fee, which is like the same as the other coin example. And then in return, you get the car registration. Yeah. Okay. And one of the main pillars when designing Move was security. Security by default. We wanted to avoid as much of the pitfalls as we've seen in the blockchain industry as possible. So duplication, double spending, and destruction are all just a few examples of what's not possible on Sui. Like if you write contracts, if any of you run any of this code, it won't compile. So you just won't physically be able to publish any contracts with these kind of errors in it. And this again is just using the principle, ensuring that digital assets behave like physical ones. Like you wouldn't be able to double spend $1 or such things. Okay, so we have the Sui object model. That's how we represent assets. The Move is the API layer. It's the layer where you can create these custom types, these custom assets, as well as the logic for manipulating and possibly deleting these objects. And then we have PTBs. PTBs is a framework that allows you to interact with all of the deployed objects on Sui, as well as create new ones and destroy them and stuff like that. So a PTB, it's basically a batch of operations. You can batch up to over 1,000 operations into a single PTB. And again, this will greatly reduce the cost of gas because executing operations together is always going to be cheaper than separately. And then these operations are executed on-chain atomically. So it's very similar to how you would see a smart contract function operate. Like everything in the function is atomic. If something goes wrong, if something throws an error, the whole transaction will revert. And it's the same with these PTBs. So it basically allows a client-side developer, like we offer languages, SDKs in TypeScript, Python, Rust, most of the common languages. And so it gives a developer with no smart contract experience the ability to interact with objects on Sui without having any smart contract experience. And so the most major use case that we've seen so far is just reducing the need for new smart contract wrappers. If you want to interact with two different smart contracts or multiple protocols on in the same atomic transaction, this can be done by default on Sui. So I'm going to go to this example real quick. Okay, so this is a DEX aggregator on Sui. So when you want to perform a swap, this will aggregate all of the different DEXs on Sui and find you the most optimal swap. So let's say if I have 1 ETH I want to swap. So it's going to go ahead and find the most optimal route for you. And you can see that the most optimal route in this case, and it's going to keep updating as I talk, but it splits the route into multiple paths, and then each path has a chain of swaps. So this is all calculated on the client side, and if I were to actually connect my wallet and swap this would all be executed on the client side with, I'm assuming, like a TypeScript SDK, no smart contract, wrapper-like functions or anything needed. So this is just like one pretty like default or basic use case of like how powerful a PTB can be. Okay, so just to summarize, we have the SWE object model. We represent assets on chain using objects, and objects can be shared or individually owned. And then we have the move layer, which is how you define these new assets, how you define the logic for interacting with these assets. And then we have PTBs, in which is the way any developer, a smart contract developer, front-end developer, can start building on SWE, start building products on SWE. And then I have a fourth secret superpower, which is user experience. So I've kind of showed you like how the developer experience on SWE can be, but we also have a really good user experience. So we think our goal is, and everyone's goal, but our goal is to adopt the mass users of the internet. You know, there's like millions of crypto users, but there's billions of users on the internet. And we see like keys and like wallets as a current blocker. There's like most people, they forget their Netflix password, their banking passwords. Like these are important pieces of information that users. I mean, I'm also one of these people that every once in a while I'll forget a password and I have to like recover it or something. And we think that this is a major blocker for the mass adoption of crypto. So we want to we have the technology and we want to meet them where the users are. And that's using typical like OAuth methods such as like sign in with Google, sign in with Facebook, sign in with Apple. We want to allow users to use what they're familiar with, but then have the power of the blockchain behind the scenes. So that's why we've used zero knowledge proofs to allow you to create a SWE account using just like a Gmail account. And you can see this in a lot of our products today. And if you're interested in learning more, you can come by our booth and we'll show you more about that. Okay, so now that's about SWE, and now let's talk about Walrus. So Walrus is a decentralized storage network. It was built by the same team that built the SWE blockchain, and it uses SWE as a coordination layer. And there's a few reasons why we wanted to use SWE as part of the coordination layer. SWE is very performant, so because SWE is so fast, we were able to handle the metadata and the payments very fast on Walrus. So Walrus is pretty fast due to this. And then the core engineering team didn't have to worry about any of the coordination of the metadata or handle payments or anything, so they were able to solely focus on the data aspect of the network. And the way we see it, and the reason why we pair them together when we talk about decentralizing the internet is we see SWE as the global coordination layer, the compute layer, if you will. So it's really fast. It can handle a lot of demand. There's the DevX and the UX are both really great. And we have a lot of composability with the object model paired with the PTBs. And then we see Walrus as the global data layer. So no matter what, when most internet apps and use cases still deal with a lot of data. So we want to make sure that you can deal with data in a good decentralized manner. So differently from other networks, we use a novel 2D encoding algorithm for storing the data and distributing it throughout the network. Most other networks, they have full replication, which means if you upload a gigabyte, every single node in that network has to also hold that same gigabyte. So this requires a lot more performance, which makes everything cost a lot more. So on Walrus, we only require, with our encoding algorithm, we only have a 4 to 5x replication factor. So no matter how big of a piece of data you want to store or how many nodes are in the network, we will only store 4 to 5x, or we'll only replicate your data 4 to 5x throughout the network. And we do this by split distributing your data into shards that are distributed throughout the network. And because of this low replication, it actually makes Walrus very scalable. On other networks, when you add nodes, you're actually adding more storage requirements because every node has to replicate the data. But when you add nodes on Walrus, you're actually increasing the performance and increasing the capacity. And even though we only replicate the data 4 to 5x, we're also very resilient. with 1/3 of the nodes down, you would still be able to write new data to the network, and 2/3 of the nodes can be down, and you can still retrieve your data. So even though we have a low replication, it does not take a cost at the resiliency. It's actually very resilient. And because we use SWE as a coordination layer, that means that data is now a programmable asset on chain. So you can create a marketplace on SWE for this data or for certain pieces of data, for example. And you can use smart contracts to manage the life cycle of data, as well as the options are limitless, really. And just to reiterate, Walrus is a delegated proof-of-stake network. So if you're interested, you can reach out to us if you're wanting to provide some storage or anything. But yeah, so the main thing is that it's cost efficient, but it's also very reliable. Okay, and I wanted to bring up very quickly this product that we have on Walrus. It's called Walrus Sites. It allows you to deploy static websites to Walrus, the network, and access them via your browser. So now we have dApps, and these dApps are usually hosted on some centralized server, which means that these decentralized apps aren't totally decentralized, because at any moment, if whoever ran the server wanted to, they could close out your website, and then you'd be kind of screwed. So we made it so that's not possible anymore, or that's not possible on Walrus. So if you host a site on Walrus, no one else can take it down unless the nodes as a unit agree that your service shouldn't be out there, if it's illegal or something. But yeah, so this is one product that we have, and it's just the tip of the iceberg. We'll be launching Walrus mainnet very soon, like within a week or so. So keep an eye out, and yeah, keep an eye out. Okay, yeah, and if you're interested in learning more, you can find the Walrus landing page at walrus.xyz. And then if you're interested more on the technical side, you can read the white paper at Walrus, at the Walrus white paper QR code here. And if you're at all interested on SWE or Walrus or how they pair together, if you're looking for some ideas to build, you can come by our booth right over there to talk to us. We'd love to talk to you all about this even more. All right, well, thank you so much for giving me your guys' time and listening, and I hope you guys are interested. And yeah, looking forward to talking to you all. Thank you.